As we continue our study of logarithms, today we're going to talk about the properties of logs. There are three properties. The product property, which says if you have log of x times y base b, that's equal to log x base b plus log y base b. The quotient property, log of x divided by y base b, log x base b minus log y base b. Power property, log of x to the p power base b is equal to p log x base b. All right, so most of the time they won't tell you. We're going to break this down, and we'll do each type, and then we'll put it together with no hints or anything. So the first set of directions say use the product property to write as the sum of logarithms. Simplify if possible. So if you notice, the first logarithmic problem has three terms in it, 2, x, and y. So we're going to write log of 2 base 2 plus log x base 2 plus log y base 2. Now, if you notice the number, log 2 base 2, if you recall from last class, that's equal to 1. So 1 plus log x base 2 plus log y base 2. And this is your final answer. Okay? Because we have variables, we cannot get a numerical value. On number 2, notice we are talking about the natural log, ln, and it's 3 times the quantity a plus b. There's only 2 terms there. So we have ln 3 plus ln of a plus b. We have no mathematical rules to separate addition when it's ln of a binomial or trinomial or other polynomial. Number 3, use the quotient property of logarithms to write the logarithm as a difference. Then simplify if possible. So again, notice on number 3, you have 2 terms. So this is log z. Whatever's in the numerator with 2 terms goes first. Log z base 7 minus log 49 base 7. Now, if I remember, I could write 49 as a power of 7. Or I could use my calculator and do change of base. So again, a couple ways to solve here. So I'm seeing this as 7 squared. So if you guys can see that base match, your answer is going to be log z base 7 minus 2. Again, because you have a variable, you cannot simplify that z. Number 4, 2 terms again. This is log 100 minus log of x to the 4th. Now, if I type in log 100 on my calculator, I'm going to get 2. So this is 2 minus. Okay, this one's a little tricky because we also have a power here. So the 4 will come in front to multiply, and it'll look like that. 2 minus 4 log x. Okay, apply the power property of logarithms. So multiplication goes to addition. So the first thing we want to do is to separate carefully. That's ln of x to the 5th plus ln of w to the 7th. And I will use parentheses. They're optional. Just helps me keep my problem a little bit neater. Okay, then the 5, because it's an exponent, moves to the front and multiplies. So it's 5 ln of x plus 7 ln of w. Here this is ln of e to the 5th. Now I know my answer is 5 here. So the 5 comes down, that's 5 ln of e. So if I recall, ln of e is 1, so I get 5. So I can follow the rules, or I can remember those other rules that we learned a couple days ago. For logarithms. Okay, so let's go ahead Let's press on. Okay, so now we're going to make it a little more difficult. Write the expression as a sum and or difference of logs, and then we're going to go the other way, if you guys notice 9 and 10. So number 7, this is log of x squared. Let me see here. X squared y. Okay, let me double check this problem here. X squared y to the third minus log of w to the fourth p to the fifth. If you guys have noticed for me, there's no number by the log. Remember, that's an understood 10. Okay, so multiplication goes to addition. So we'll go ahead and split the first term, and then we'll look at the second term using that log rule. So this becomes log of x squared plus log of y to the third power minus, and this is log of w squared plus log of p to the fifth. So what happens here is that negative sign distributes. So this becomes log of x squared plus log of y cubed minus log of w squared minus log of p to the fifth power. And then we have one more step to bring our exponents in front as a multiplication. 2 log x plus 3 log y. Okay, that should be a negative sign there, class. I miscopied. Minus 2 log w minus 5 log p. Okay, now, another way to look at this is say, I remember that x to the negative n is equal to 1 over x to the n. So we could rewrite those with negative exponents and save a little bit of work here. I'll show you what I mean. So let's look at number 8. I'm going to write number 8 as ln of the cube root of x squared minus ln of w plus z. Remember, we cannot split up addition here. Okay, so let me choose another color. Let's see here. I'm not sure that this pin wants to agree with this here. There it is. So let's do ln of the cube root of x squared minus ln of w plus z. Okay, so we have to rewrite that term there. So that's ln of x to the 2/3. I'm going to do this, plus ln of w plus z to the negative 1. Okay, let's go ahead and leave that as a minus sign, class. I was thinking about the next step, so we may want to use this coming up, okay? A little bit premature here. Okay, so bring your 2/3 down, so that's 2/3 ln of x minus ln of w plus z. Okay, and there's your answer. All right, so when we go to the other way, we can go ahead and move those negatives up. Here's what I mean. This is log of x to the third plus log of y to the negative 4. I'm going to go ahead and take the sign with the number that's in front. Plus log of z to the negative 1 plus log of w squared. So what we have is log, you have x cubed over y to the 4, because it's negative, it goes on the bottom. Z is on the bottom because it's negative sign, and w squared. All right, so again, let me write that a little bit neater. I have a little more room than I thought. So one more time, that's log of x to the 3rd. Okay, because the y has a negative exponent due to the minus sign, you have y to the 4 in the denominator. You have z is to the negative 1, it also goes in the denominator, and w squares goes in the numerator. Now, you could look at it that way, or if you notice, the two terms that have a subtraction are in the denominator, and the other two are in the numerator. And I'm just looking, so the x cubed goes, and the w squared, the y is to the 4th power, and the z. So here, this is two different terms. So this is log of 4x minus 3 divided by x. Now, I would not do any simplification here unless you can factor and simplify, which we can. All right, now we've already talked about change of base here. So notice you can either use log or ln. So to change this base, what we can do is we can do log of the first term over log of the denominator. So we will look at that. So we're going to do log 15 divided by log 7. And here we're going to do log of 0.3 divided by log 5. And let me just double check those numbers there. Log 15 divided by log 7. Log of 0.3 divided by log of 5. So if I type that into my graphing calculator, I get log 15 divided by log 7. We'll round to 4 decimal places again. So that's approximately 1.3917. Log of 0.3 divided by log of 5 is approximately let me write that a little bit smaller here. So we're going to say approximately negative 0.7481. That is, again, log of 0.3, the argument there. And then notice the exponent is, the base is below, so we're going to put that log 5. Okay, and there we have it.